So for number 18, we have given segment FK is a median. All right, that's important. If it's a median, medians we split into 3 equal parts. So even though I haven't finished reading it, I know median means I want to split this into 3 equal parts because it's a median. And it says the ED equals x minus 5. And KD equals negative 8 plus x. Find the value of x. Oh, I guess I didn't need the median part. But a median also bisects the side. That's what I need to know for this one. So the side has been bisected by the median. And if it says that ED is x minus 5, E to D, that's the entire length, is x minus 5. And that KD, this section, is negative 8 plus x, or x minus 8, same thing, x minus 8. Find the value of x. Okay, so because I marked with the 2 red lines that these 2 pieces are congruent, I could either write x minus 8 again over here for EK is also x minus 8, or I could say that it takes two of the x minus 8s to make the entire length x minus 5, which is the way I like to do it, is 2 times. Or I'll do the adding. So if one side is x minus 8 and they're the same, this side is also x minus 8. So I can make an equation, x minus 8 plus x minus 8 is going to equal x minus 5. So if I add the 2 pieces together, they make the whole thing, which is segment addition postulate, if you remember that. Okay, so now I can combine like terms. I have x plus x, or if you have trouble with that, what if I have x plus x? How many x's do I have? If write it like that. And then minus 8, minus 8. Group them together if you have trouble figuring out if it's x squared or 2x. How many x's do I have? Well, this way you can see it. There's 2 of them. So that's 2x. And negative 8 minus 8 is going to give me negative 16. And then bring down the x minus 5. All right, so now I have 2x minus 16 equals x minus 5. I need to get my x's together and my non-x's on the other side. So I'm going to subtract x. And 2x minus x is just x. Minus 16 equals negative 5. So my last step is going to be to add 16. So x equals 9. Negative 5 plus 16 should be 9. And it just said find the value of x, so I am finished. Okay, so then number 19 should be a similar problem. Given the segment JG is a median, and the JG is 4x minus 1. Let's see. JG is 4x minus 1. Over here is 4x minus 1. And JF is 2x plus 5. So this side is 2x plus 5. Find the length of JF. So I'm going to find the green one. So again, because this is a median bisects the side of the triangle. So GJ is congruent to FJ. They're equal to each other. So since they are congruent, I can say they are equal. Mm-hmm. It does, right?
16 minus 5 is 11.
Wouldn't it equal 11?
Yeah, it does equal 11. I don't know what I was thinking.
I didn't want to interrupt.
Yeah, please do. That is 11. I don't know how that would be 9. Thank you for asking a question. If it was 14, which it is not. I think that's what was happening in my mind. Okay. So now I have, okay, so it's bisected, so it means that these two pieces are equal to each other. So that means that 4x minus 1 is equal to 2x plus 5. So you do have to be careful of what you're dealing with, because these are similar problems, number 18 and 19, but they're not, based on the given information, they're not set up the same. Okay, so make sure you pay attention to what you're dealing with. And then you can solve. So I'm going to get the x's to the left, so I'm going to subtract 2x. 2x minus 1 equals 5. And then I'm going to add 1. So 2x equals 6. And now I can divide by 2. And x equals 3. But this problem doesn't say to find x. It says to find JF. And JF is what I marked as 2x plus 5. So I need to find JF. And JF is 2, but instead of x, since I know what x is now, I'm going to do blank parentheses plus 5. And then I'm going to take x is 3 and plug it in the blank. Anytime I have a variable that I've solved for and I'm plugging it back into a formula, I always write it with blank parentheses and then fill it in. When it's a positive number, it doesn't really make too much of a difference. But if you're dealing with a negative number, sometimes that makes a huge difference by just having the blank parentheses there. It makes a difference of seeing, when you look at it next time, minus 3 or times 3. So even Algebra 2, when I teach that class, I teach the same thing. If you have a formula or an equation that you're filling in the variable for, always write it with blank parentheses and then fill in the variables. Plug in the numbers. All right, so now I have 2 times 3, which is 6, plus 5. And 6 plus 5 is 11. So that means that segment JF equals 11. Okay. All right, so number 20, we have that segment FP is an angle bisector. So that's a key term. Bisector, an angle bisector, I hope you guys have figured out by now that an angle bisector splits the angle into 2 equal pieces. So if FP is a bisector, that means, so this is the bisector, it means that these two angles, angle 1 and angle 2, missed the button, that angle 1 and angle 2 are equal to each other. It's been cut in half. Those two are equal. And then it tells me the measure of HFP, so angle 1, could have just said angle 1. Okay, so that is, find the measure of HFP. That's what I'm trying to find. this is what I'm looking for. And it gives me the measure of angle 2 is 2x plus 1. So angle 2 is 2x plus 1. That's over here. 2x plus 1. And then it tells me that the measure of angle 1 is 4x minus 9. So that's also what I'm looking for, is 4x minus 9. And this is what I'm solving for right here. All right, so because of the angle bisector means that they are equal. So what is equal? Well, the two angles are equal. So I'm going to take what I have written down as the variable or the expression for each angle and make an equation. 2x plus 1 equals 4x minus 9. And then I can solve for x and plug it back in to find the measure of angle 1 or the measure of angle HFP. All right, so I'm going to subtract the 2x from 4x. So 1 equals 2x minus 9. And now I add the 9. So 10 equals 2x. And I can divide it by 2. So 5 equals x. But again, I'm not asked what is x. I'm asked for the angle. And I know that the measure of angle HFP is 4x minus 9. So instead of x, I'm putting a blank, minus 9. And then I take the value of x and plug it in. So the measure of HFP equals 20 minus 9. So it's 11. So the measure of angle HFP is 11. All right, so that was an angle bisector. It looks like number 21 also has an angle bisector. Number 21 says that PA is an angle bisector. And I know a bisector means I cut the angle exactly in half. But we don't know if it's going to be exactly the same. Chances are it's probably not exactly the same. I might be solving for something different. Okay, so PA is the bisector. Right there, same place. Bisect means cut in half. So angle 1 is congruent to angle 2. This time I'm going to find the measure of PAB. All right, P to A to B, that's angle 2. Whoa. From P to A to B says I'm solving for that angle. And then it says if the measure of angle 1 is 12x and the measure of CAB is 20x plus 2. Okay, so let's see. We have the measure of angle 1 is 12x. Angle 1, that's 12x. And then we have CAB. Well, where's CAB? Here's C to A to B. Okay, so this one is different than the last one. That's weird. So now I'm looking at the large angle. That is 20x plus 2. So from the large angle is 20x plus 2. Okay, so looking at this with angle addition postulate, the two small angles added together will equal the large angle. And if I know that it's bisected, I know they're equal. So I could say 12x. I could say 2 times 12x, or I could say 12x plus 12x. It's the same thing. So 2 of the small one equal the big one. So 2 times 12x equals 20x plus 2. No? Okay. Let me do that differently. Okay. So if this is 12x and it's equal to angle 2, that means angle 2 is also 12x. And the large blue angle, highlighted blue angle, is made up of the 2 smaller angles. So if I add these together, they're going to equal the big one. So 12x plus 12x is going to equal 20x plus 2. Does that make more sense written that way? Okay. Okay, good. Then I will go with that method. All right, so then 12x plus 12x gives me 24x. And 24x equals 20x plus 2. And now I'm just going to solve. So I'm going to subtract 20x. So 4x equals 2. And then if I divide by 4, then x equals 2 over 4, but 2 over 4 is the same as half. Or I could say 0.5. If you prefer a decimal, that's fine. Whichever way you'd rather write it. Because this doesn't say find x, so I'm going to have to plug it back in. I'm going to use half because I like 1/2 better than I like 0.5. And then I'm going to find the measure of PAB, which was the highlighted yellow, which I know is 12x. Because I know that they are the same. All right, so the measure of angle PAB is going to equal 12x. But instead of x, I'm doing parentheses, and I'm going to plug in my value of x is half. So the measure of angle PAB equals half of 12. Half of 12 is 6. All right. The next section is going back to Unit 4. We're going to determine if the pairs of triangles are congruent by side, 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 angle, side, angle, side, angle, 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 side, or HL. If the triangles are not congruent, write not possible. Okay, so remember, you kind of have a guide because all the postulates are written here. SSS, SAS, ASA, AAS, or HL. And if the letters can't line up to match one of those 5 things, then it's not congruent or not possible. All right, so here we're just going to go through and mark what is given. Mark the given information. Mark what you know. So these are separated. This is a side, and then we have an angle, and then we have another angle. But I do need to make sure they match also, so I need to label the other one. Here's a side, here's an angle, and here's another angle. So it looks like they match. Okay, so now that I know that they match, I'm just going to look at one of them. So and the letters that I have 2 A's and I have 1 S. So I'm going to write the one that I have 1 of. I have an S, and then I have 2 A's.
ASA.
Well, I want to see
It's 280.
this side.
AAS.
This side is touching this angle down here,
Yeah.
right? So this S is touching this A.
So
So I'm going to write that. The S is touching an A.
Okay.
What about this other angle, the one across from, is this angle touching this side?
No.
No. So where can I write the A that's not touching the S?
Can you?
Can I write it up here where it's not touching the,
Yes.
I can put it on this side, right?
Yeah.
Yeah. Because it is touching, there is nothing,
Yeah. It's touching the area right here.
yeah. So I have SAA, and then I'm going to look at my postulates. I don't see SAA, but I do see AAS. And so if I were to flip that around, wouldn't it be the same thing?
Yeah.
Yes.
So is it okay to do that?
Yeah.
So this is angle, angle, side. So what the letters inside the triangle are mapping how to write the letters for the postulate.
Okay.
Because this S was only touching one of the A's, the only way I could write those 3 letters where it's only touching one of the A's is to put the S on the side, like on the outside of the letters.
Okay.
Either way. All right, so now let's look at the next one. I have a side, and then I have an angle, and this is an angle, and this is a side. Pretty sure everybody is okay with that, like just labeling the sides and the angles that are marked.
When the top right there be angle 2? The top.
Up here,
Yeah. Let me angle 2, right?
there's no information there.
Wouldn't,
No.
it would be the one in the middle because it's in a vertical angle.
Yeah, in the middle,
Vertical angle right there. Right?
yes, it is vertical angles, and you always have to know vertical angles. So I know that this side is the same as this side,
So that'd be angles. Then, right?
or this angle is the same as this angle, so that's an angle.
So ASA again, right?
AAS, yes.
Oh yeah.
Right, because if you look at just one of the triangles, there's only one side, so that's a good place to start. Here's the side. The side is only touching one of the angles. It's not touching the other angle. So you want to write your letters to where it's only touching one of the A's, not both of the A's. So the other A has to go on the other side of the first A. So angle, angle, side.
So angle side then, right?
Mm-hmm.
Okay.
Okay. So now number 24.
I mean, when you give the side, those two right there are sides, right?
Those are sides.
Yeah.
But whenever you have a right triangle, what are you supposed to check first?
90 degree.
Yeah, 90
The
degrees.
box right there, 90 degrees.
It is. It's a right triangle. It's 90 degrees. So whenever you have that, you always want to check for hypotenuse leg first.
Okay.
So for hypotenuse leg,
It has to be over 180, right? No, like 180, right?
you have to have a 90-degree angle. You have that. You have to have a leg marked. Do you have a leg congruent? Yes.
Yeah.
And you have to have the hypotenuse marked as congruent. Is the hypotenuse marked congruent?
No.
Yeah.
Nope. So it failed the HL test. It's not HL.
Okay.
So you have to do that first. And now since it failed that test, now we're going to see, is it something else? So now we have a side, an angle, a side, an angle. Is there anything else?
I mean, a side right there. I mean, where they like there?
Over here?
No, on the other side.
Here?
Yeah. No.
Here?
Above that, right there. Yeah.
That's not marked
Can
though.
that be a side though?
It is a side of the triangle, but it's not marked with anything.
Oh, nothing's marked. I mean, nothing else is marked.
Right, so this is not congruent.
Okay.
Or not possible. I'm going to do not congruent.
So it's not. So there's no like solution for it basically.
Right. We don't have enough information to say that these are congruent, even if they are. We don't know that. Okay, so number 25 on the next page.
There's no side.
Here's the side.
Two sides.
Here's the side. Here's the side. Here's the side. So we have all of the sides. Is there anything else we can mark?
I mean, a vertical angle right there.
Vertical angle.
So this angle, right?
No, side and side.
Yeah.
So we marked that. And then to figure out what you have, you look at the letter when there's only one A. So that's what I'm going to look at is the A.
Angle side to side.
So I'm looking at the A.
Right, sorry.
And I want to write an A. And now I need to figure out where am I going to put the S's.
On the side of it.
Yes, because on the left side the angle is touching a side. So I'm going to put an S on the left side. On the right side of the angle, it's touching a marked side. So I'm going to put an S over there also. So I have side, angle, side.
So ASA.
SAS.
I mean, yeah, SAS.
Yes. Okay, then we have this one, and this one's been tricky for you guys.
What's the triangle mean?
That means parallel lines. It's an arrow, and it means parallel lines. So
I think I've seen that before in the homework before.
from Unit 4.
Okay.
So this line is parallel to this line because of the arrows. That's what those arrows mean.
So it'll be side, right?
Well,
That's the angle, I mean.
that just tells you that the lines are parallel.
Okay.
But the vertical marking tells us that's a side, and that this is a side.
It's vertical, so is there angles?
And there are vertical angles right here.
Yes.
So we have A. And then there's the other thing, which is why you needed to know it was parallel, is Z angles are Z same. You remember me saying that?
Z angles are the same?
Z angles are Z same. Because it makes a Z shape.
Oh yeah. Backwards Z kind of.
It doesn't matter, yeah, either direction. It could have gone the other way. I did it backwards, huh? It doesn't matter. You could go either direction with it. And now I know that the alternate interior angles are congruent. So that means that this angle is the same as this angle.
So angle, so when it's side, angle, side,
Side, angle, angle.
side, angle, angle.
Or angle, side.
So that is another angle and another angle. But actually, this one's a really special one. Normally, this doesn't happen all the time, but this could be Z angles going the other direction also, because there's two transversals.
So it can be ear or the basically inside.
So the Z, it's Z angles both ways. So that means I have another set of angles that are marked the same. So this one is, I'm put 3 lines, and it matches this one with 3 lines. So I have 2 sets of Z angles because there's 2 transversals. And so that's another angle that's marked the same. So there's a lot here. This could be, like you guys said, angle, angle, side. If I went with this one, angle, angle, side, or the other way, angle, angle, side, or angle, side, angle. So this one has 3 different ways that it's congruent. So this one is definitely congruent. We have angle, side, angle. We have angle, angle, side. And we have angle, angle, side in another direction. So that had a lot of congruent pieces. And then number 27, we have another right triangle. We know right triangles, we want to check to see, does HL work? Because it's 90 degrees. So for HL, 90 degrees, yes. Is there a leg marked the same? Right here,
Yes.
right here, yes. Is the hypotenuse the same?
Yes.
Yes.
Right, because it shares a hypotenuse, so yes. So this is HL.
So it passed the HL test.
It did. HL is hypotenuse leg. All right, so for number 28 through 30, it says to draw a picture to solve the problem. It says NP, ray NP, is an angle bisector of angle MNQ. If the measure of P in Q is 5x minus 8 and the measure of M in Q is 4x plus 8, solve for the measure of M in Q. All right, so before we get to that second sentence, really we just need to set up a picture. Ray NP is an angle bisector of angle M in Q. So the first thing we need to do,
Triangle.
We need angle MNQ. It's not a triangle, it's just an angle.
Oh.
Angle MNQ.
So just like drawing any angle, right?
Right, so there's mine. And label it MNQ, where N is the vertex of the angle. And it says that NP is an angle bisector, so it's cutting it exactly in half. NP is the bisector. So from N, going straight out the middle, that's NP, and it cuts this into 2 equal pieces. It's been bisected. So this problem just got a lot easier just because we can see what's happening now. Okay, so it says P and Q. All right, so there we have P, N, Q. So we're talking about this side. Is 5x minus 8. And the measure of M and Q, all right, where's M and Q? M, N, Q. Yep, that's the whole thing. Is 4x plus 8. Solve for M and Q. So I want to find out what the large angle is. So angle MNQ is what I'm looking for. So I need to set up an equation to solve. And I can see I have this one small piece and I have something for the whole thing. But I know the 2 small pieces are the same, so I can fill in the 5x minus 8 on the other side also because they're the same. And now I have an equation. Five x minus 8 plus 5x minus 8 is going to equal 4x plus 8. So this is also 4x plus 8. All right, so I have an equation. And now I can combine like terms because I have 5x and 5x, and they're on the same side. So it's 5x plus 5x minus 8 minus 8. So I'm just rearranging.
Kind of bathroom.
All I did was rearrange that. So it looks more obvious that I want to put them together now because 5x plus 5x is 10x. And then negative 8 minus 8 is negative 16. And that equals 4x plus 8. So I haven't solved anything yet. I just simplified it. I combined like terms. Pieces that are the same, I put them together. X terms, non-x terms. Now I'm going to solve it. So I'm going to subtract 4x. So I have 6x minus 16 equals 8. And I've run out of space, so I'm going to bring it up here. 6x minus 16 equals 8. And then add the 16. So 6x equals 24. And then I can divide by 6. So x equals 4. Once I have that x equals 4, and I'm looking for the measure of M and Q, and I know M and Q is 4x plus 8, I can take it and plug it in where x is. Right there, 4. So the measure of M and Q equals 4 times 4 plus 8, so 16 plus 8, so that's 24. All right, so number 29, there is a correction on number 29, right here. MZ, it says MZ equals 5y plus 14. We need to make that 5y minus 14. Because if we don't change it, we end up with everything being a negative side length, and we can't measure with a tape measure a negative length. It doesn't make sense. So we need that positive to be a negative. All right, so now we have M is the midpoint of segment KZ. If segment KM is 3y minus 6 and segment MZ is 5y minus 14, what is the value of y? So we're just dealing with segments. So my picture is pretty simple. It's just a line segment. And M is the midpoint of KZ. So it's from one end is K, the other end is Z, and in the middle I have midpoint M. And if it's a midpoint, then that means it's split in the middle, exactly in the middle. Both sides are equal to each other. All right, so once I draw a picture, even though it's a very simple picture, it makes this problem a lot easier. Km is 3y minus 6. And MZ is 5y minus 14. What is the value of y? Well, because it's the midpoint, I know those two pieces are equal to each other. So I can set that up as they equal each other. 3y minus 6 equals 5y minus 14. And all I need is the value of y. So I'm going to subtract the 3y. Negative 6 equals 2y minus 14. Add the 14. So 8 equals 2y. And the last thing is to divide by 2. So 4 equals y. And then the last part says, what is the value of line segment KZ? So that's the one from above. Oh, KZ is the entire length. If I want to know what the segment of the entire length is, from K to Z, I can solve for one of them and double it, or I could plug y is 4 into both of them. So if I have 3y minus 6 is half of it, and I plug in the 4, then I get 12 minus 6, which is 6. And then I multiply times 2.
No, it's a review.
So KZ equals 2. Yes, KZ equals 12. I said 2. KZ equals 12.